Hello, 8th period AP Calculus BC. This is Maeher and Harrison Frith's Chapter 5 video project. So for our equation, we have f of x equals 1 plus x to the 2/3 power. And to find the intervals on which f of x is increasing and decreasing, we need to find the derivative. So the derivative for this equation would be 2/3 x to the negative 1/5 power. And then we set that derivative equal to 0 and solve for x to find the increasing and decreasing intervals. In this case, x is undefined at 0, meaning that there is no solution which satisfies this equation. So to find the concavity of this equation, we have to do the second derivative test. And in this case, the second derivative is negative 2/9 x to the negative 4/5 power. And then we have to set that equation equal to 0 and solve for x. And once again, x is undefined at 0, meaning that the critical point for this equation is at x equals 0. And in this case, based on the first derivative test, the equation is decreasing until 0 and increasing after 0. And based on the second derivative test, the graph is concave downwards before 0 and after 0. So now we're going to be drawing out the graphs for the original first derivative and second derivative equations. So for the first derivative, just in orange, kind of like an open book shape. The first derivative is that characteristic graph that we see all the time in calculus, in math. Third and first quadrant. And then the second derivative graph is coming along nicely, going right along the first derivative, and in the fourth quadrant, right along. And that is our graphs. Now we're writing out our answer for number 2 using MVT to find f of x in the interval 1 to 2. Right now, Harrison's just writing out the equation for f of c, which is f of b minus f of a over b minus a, right? So now we have him writing out the points, doing the math. So now we have our f of c, 0.587 over 1. Yep. And that is our answer. Thank you. Now we have number 3. A closed box with a square base must have a volume of 5,000 centimeters cubed. Find the dimensions of the box that will minimize the amount of material used. So Harrison drew out the box with the two bases and the height, little cube action. So to find the dimensions that would minimize the amount of material used, we have to write down two equations: the volume of the cube and the surface area of the cube. And the volume of equation is b squared times h equals 5,000 centimeters cubed. And then we put that in terms of h, and then we get h equals 5,000 over b squared. And then the surface area equation is just 4bh plus 2b squared. And now we're putting the surface area in terms of b and Harrison is just taking the h equation that we derived from the volume and sticking it into the surface area equation, so we have one variable in that equation. And now Harrison is simplifying the equation, taking out the b's, making it a little less crunchy, a little easier to work with. Now we are continuing to simplify our new surface area equation in terms of b. So remember before it was 4 times 5,000 over b plus 2b squared. And now we multiply the 4 and 5,000 and we get 20,000 over b plus 2b squared. And now we can take the derivative of this equation, which would be negative 20,000 over b squared plus 4b. And then we set that equal to 0 and we solve for b. So to solve for b, we subtract both sides by 4b. We get negative 4b equals negative 20,000 over b squared. Multiply both sides by b squared. And we get 4b to the third power equals 20,000 because the negatives cancel out. And then we divide both sides by 4 and get the cube root of 5,000 to solve for b. And you could just leave it here, or you could make it into its decimal form where b would equal about 17.1. And now Harrison's just writing it on the number line, decreasing and increasing. So we're not done with our work yet. We still have to solve for h. And remember, our h equals equation was h equals 5,000 over b squared. And we're going to plug in our value for b, which was cube root 5,000. And now Harrison is solving for that. But in this case, this closed box with a square base ended up being a cube. So the b value and the h value are identical. And now Harrison is just finishing up the work. He plugged in the b value. Writing down the answers. Yep. So 5,000 over 5,000 to the 2/3 power equals h, which equals 5,000 cube rooted feet. So the dimensions of this box would be cube root 5,000 by cube root 5,000. Thank you.